So we're going to take a look at a formula here about stream flow rate. So let's take a look at the information and try to answer some questions about it. So we have the flow rate formula says Q equals A times V. So Q is the flow rate. So the speed at which the water is moving through a given spot. A is the cross-sectional area of the stream and V is the velocity, right? So we've got some river stream thing flowing, and then the stream has some kind of shape. Let's just say it's like a tubular kind of shape going on here. And so if we take a slice down through perpendicular to the flow of the water, that's the cross-sectional area they're talking about. And so we want to kind of measure the speed of water flowing through that area. All right, so units must be consistent. This is always true in formulas, and so we have to pay attention to that. So the velocity is meters per second, so that's the V here. So to calculate that Q flow rate, we've got our velocity in meters per second and our area in square meters. So we're taking some number in square meters, that's my A, and I'm multiplying it by some number that has meters per second. And if you think about multiplying fractions, you got to have a common denominator, which means this should have a denominator, and then we multiply the numerators and multiply the denominators. So meters squared is meters times another meter means I'm going to have cubic meters, which is some volume, some chunk of water per second. Okay, so volume per second is what we're getting here from this formula. So what must the units be for Q? They must be meters to the third power divided by seconds, or written in pretty math like that there. All right, if we solve this for V, we would have to divide the A to the other side. So then my original formula says Q equals AV. I want to get the V by itself, so I have to break this multiplication by dividing A over to the other side. A divided by A is 1, so that leaves Q over A on the left, and now I have solved for V. So V here is Q over A. And then we get to apply some situations to these versions of the formula. So a stream has a cross-sectional area of 5 square meters, and we're sticking with the same units we started with, which is important. So I'm just going to make a note over here. For this part, V is 5. I'm going to write it as meters squared. The velocity is 2.4 meters per second, and that matches what I'm supposed to use for this formula. So, oops, I labeled that wrong, didn't I? That right there should be my A. Second number is my V. So A, the area is 5 meters squared, and the velocity in this situation is 2.4 meters per second. And they want me to find out what's the flow rate, so I'm going to use the first version of the formula because it finds flow rate. So then to get that, my Q is just going to be this number times that one. And I don't need to write the units, well, I guess I'm going to here, but there's probably on the problem, it already has the units for me. So I just need to know what is 5 times 2.4, knowing that the units are right, okay? And that's important to check. 5 times 2.4 is like what, 12-ish? Calculator, please. 5 times 2.4, hey, 12, nice job. That equals 12, and so that's my answer here. What's the flow rate? The flow rate is 12, and that would be cubic meters per second. All right, that wasn't too bad. Next one. What is the water speed? Water speed, that would be my velocity, speed, so V equals what? If the flow rate, so that's my Q, there, and the cross-sectional area is 11 square feet. Okay, so I have good units. Meters cubed per second, that's a check. Square feet, ooh, no, can't have square feet. I need square meters. All right, so I'm gonna have to do a conversion. So that means we're going to have to look something up. And so let's see, I want square feet to meters. Looks like lots of people looked this up. All right, and so what was I given here? So we don't even have to do any work. It does it for me. That's kind of crazy. 11. So if I put 11 square feet there, it says it's about 1.0, I'm going to go with all those numbers, 1.021, 1.02193. Okay, let's try that. So let's see, A looks to be about 1.02193. Did I get that right? So it's kind of cool that you can just surf the web and Google or some other search engine will do that conversion for you. If you wanted to do it yourself, then what I would first do is find out how many feet are in a meter, feet to meter, and then make the conversion from there. So let's see, 1 foot is 0.3048 meters. Or what's the other way? If I start with 1 meter, it would be 3.28 feet. So meter, I like the 3.28 one better. All right, so other ways to double check this conversion if you're not happy with that calculator. I like the calculator, I think it's pretty cool. Let's go to a new page to fiddle with this. So unit conversion, sometimes we just have to do it ourselves because the computer can't do one that's too complicated, but this one's not bad. Suppose I know that 1 meter is equal to 3.28 feet. And I want to know what square feet and square meters. So then I just square both of these. So square that sucker, square that sucker. So this tells me that 1 square meter would be whatever 3.28 times 3.28 is. So calculator, 3.28 raised to the second power, and Google says it's 10.7584. 10.7584 square feet. And again, just kind of think about that whole thing. Let's suppose this is 1 meter by 1 meter. That 1 meter can be broken up into 1, 2, 3 and a little bit feet in each direction. So 1, 2, 3 and a little bit. If you kind of draw out a grid of square feet on there, you can see that a square meter is a whole bunch of square feet. So we have 9 full square feet, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then all of these partials add up to almost another 2 square feet inside of a square meter. It's kind of the geometry of the situation. So now if somebody says, hey, I have 11 feet squared, can you change that to meters squared? That's feet squared. I would say, sure. I will just do a little fraction multiplication here, put feet squared in the bottom to get rid of it, meters squared there. My equation above says 1 goes in the top and 10.7584 goes in the bottom. Then if I then ask my calculator, what is 11 divided by 10.5784, did I type those in the right order? 7584, oops. And again, I'm dividing because this number is in the bottom of the fraction. So 11 divided by that. I can type it right. So 7584. Back up, back up, back up, back up. 7584. I get about 1.022. Did I write down what that calculator told me before? Where'd you go? Back page. Yeah, if I round that to the third decimal place, it'd be 1.022. Why isn't this number exactly the same as the other one? Well, rounding. So the calculator online did a slightly different rounding scheme than I did, but they're in the ballpark. All right, so a couple different ways to come up with that conversion, and you got to make that conversion, otherwise you can't use the formula. If the units don't match, the formula just doesn't work. So now I have this in the right units, which is meters squared, and I know Q right there. So Q is that 15. That was meters cubed per second. I want to find the velocity, and so we have a way to find that right here by taking Q over A. So V is going to be the amount Q, 15, divided by the amount 1.02193. I'm going to go with that other calculator's version, the first one, but 1.022 probably would work just fine. So calculator again. And 15, right. Go calculator. There we are. So 15 divided by 1.02193, or that 1.022 should be good enough. And I get 14.678. And I was probably given specific instructions on how to round 1 decimal place. So 14.678, so that'd be 14.7-ish. So this answer here should be about 14.7, and the units should be meters per second. All right, I hope you found that useful and informative. Take care, do good math, see you in the future.